Hello people, welcome to Night Out Notes. In the previous video, we learnt about scheduling, right? In that we have learned two main concepts of scheduling, serial and non-serial scheduling. Serial scheduling is always considered as correct because transaction executed one after another. But in real life examples like Google Pay, Amazon, Flipkart and any other UPI transactions, users use the database simultaneously. Like it uses mostly non-serial scheduling only. But this raises an important question. How do we know whether the non-serial scheduling is producing the correct answer every time? This is why we need serializability. Serializability is a process of checking whether the non-serial scheduling produces the same result as the serial scheduling. If yes, the scheduling is called as the serializable. Like we are taking the reference of the serial scheduling and we are checking with the non-serial scheduling whether it producing the same answer, then it is considered as a serial schedule itself. Like see, suppose we are having many ways to complete some work, like method 1 takes one task after another, like we are willing to place this pen, after that we are having another pen with us, we are placing one pen here and then we are trying to take another pen and we are placing that pen again there itself. Like it's like a step-by-step process. Like see, we are having this pen and also we are having this pen, we are keeping this pen this side and then we are move this pen and we are moving this pen this side. We are not doing these things simultaneously, right? Both are doing after one after another. Like method 2 may have some option like we are willing to place two pens willing to be collected at the same time and be placed it beside at the same time itself. If both methods finally gives exactly the same result, then method 2 is considered as correct. Like when we are picking this pen and we are placing here and two pens are picking and two pens are placing here, when both the pens are placing left to right, if second method also giving the same result as the first method, then it is correct, considered as the correct one. If non-serial schedule produces the same result as serial schedule, then non-serial schedule is considered as serializable. The serializability is used to maintain data consistency, like everywhere the data needs to be same. Allows concurrent execution. Concurrent executions are nothing but multiple executions can be done at a single time. Prevents incorrect results. There may be a chances of incorrect results, right? Using serializability, there will be no incorrect results and always the database remains correct. Maintains database correctness. This is what I said. Prevent incorrect results, which meant by database correctness. And also it improves the database performance. We are having two types of serializability, conflict serializability and view serializability. Conflict serializability. If a schedule can be converted into a serial schedule by swapping only non-conflicting operations. Here we are not swapping overall things. We are only swapping the non-conflicting operations. You are being confused. What is this conflict actually meant by, right? Two operations are said to be in conflict when they belong to different transactions. If they belong to different transactions, it is considered as being conflicted. They access the same data item and at least one operation is right, then it will be considered as conflict. See, I am having this example. Read operation and write operation of the same transaction, same operation, and write and read and write and write, all these things are considered as the conflict operations. Because when we use only read of the same operation, nobody can changes the data because only they are reading, right? So there will be no conflict. Read and write, one transaction is reading and another transaction is changing, so there may be a chances of conflict. And write read, in this transaction one are reading, another is updating the data. Wrong information may be obtained in the read operation, right? So that there may be a chance of conflict here. Write and write, both the people are updating the same data here. So the last write and write, both the transactions are updated at the same time, right? So one can overwrite the first one, like last who is updating can update the first one rewritingly, right? So there may be a chances of conflicting. Let's see this simple example. We are having transaction 1 and transaction 2 here. Some person is reading the air. Transaction 2 is also reading, writing and writing. Here see, is this conflict serializable? We cannot understand it, right? So first to solve this conflict serializability, we need to draw a directed graph. Like we are having only two transactions here, right? So we are writing T1 and T2. Let's see how the transactions are going. Based upon, we'll draw the directed graph. Let's see here, read of A. Do we have any write of A here in any case? See, in the other transaction, see, we are not having here read of A is read of A, there will be no conflict, and write of A is present here. So the graph will be like transaction 1 is directing towards transaction 2. Next we'll go to write of A. We are having issue with write of A, like read of A also having an issue, and write of A will also be having an issue. So read of E is also there. So the directed graph will be again like this only. Write of A, and here write of A and read of A, everything is there, right? So read of A is already cancelled. So write of A and write of A, we are also having the conflict with write and write, right? So both the things are directed towards T2 only. This is not a cycle. See, there is no cycle here. Because it is not having any loop or a cycle in that, so we can say that it is serializable. If there is a chance of having loop or something like that, then we can say it is not serializable. Using this, we cannot say which transaction is happening first and which happening next, right? Using this degree, we can say that, see, in which direction it was representing the things, like all those transactions are representing T2 only, right? See, direction is representing T2 only. So which is not having any direction like that, it will be executed first. So T1 will be executed and then T2 will be executed. This is what happens in the conflict serializable. Let's understand when it is having some loop. Yeah, let's consider another problem. T1 and T2, read of A, read of A, write of A, and write of A. Here see, we are having read operation, read and read, which will not be having any issue, right? And read and write here. See, so we are having issue with that. Both are conflicting. So transaction 1 and transaction 2. So directed graph towards this, because we are having the conflict raised, right? Next we'll check this write of A. This write of A is having the conflict with this write of A. So see, this will be having like a loop and a cycle, right? So it cannot be serializable. A simple shortcut rule you can remember, like if there is no cycle, it can be serializable. If there is cycle exists, it cannot be serializable. Next one, view serializability. If a schedule produces the same final result as the serial schedule, in this view serializability, we are not drawing any directed graph like conflict serializability. We are just comparing the views of two tables. Like in this every transaction, we are seeing the same data. It would have been serial in serial execution. Like we are comparing this serial execution how it looks and view serializability how it looks. Like we need this serializability just because to check whether every transaction is seeing the correct values. Now we will consider this using a simple example. We are having serial schedule here and non-serial schedule here. We are considering the initial value of A as 100 rupees here. See, first we will need to check the first condition. What is the first condition? First we need to check which transaction is reading. Both the transaction are reading the same operation. Here see, we are reading the transaction 1. Reading transaction 1 as A. Here we are reading the transaction 2 as A. By this only we can say that it is not serializable. In the first condition, it should satisfy that both the transactions should read the same operation of the transaction only. Here we are reading both separate transactions, right? So it can be said that it cannot be view serializable, like non-view serializability. Let me consider the another example. In the both cases, starting we are reading the same transaction in the same transaction, right? Here see, we are reading from the transaction 1 itself, and here also we are reading from the same transaction. And let's consider here we are writing A is equals to A minus 50 rupees. So in this we are rewriting the transaction as A minus 50 rupees. So the value will be left like 50 only here, right? Here also if we are doing the same, we are left with 50. The answer is same. So that view serializability is done here. We can do this view serializability here. Yeah, hope you understand the serializability concept clearly. Hope you like this video. Until then, don't forget to hit that bell icon and subscribe to my channel so that you'll get more informative videos like this. If you found this video really helpful, please like and share. Meet you in another video. Bye bye.